Okay, so over the course of the next 10 to 15 minutes, we're talking a little bit about what is Khalani, because we've gotten a lot of questions about what Khalani is for comparative to how long we've been around. So I'll give a brief summary of that. I'll talk about the off-chain versus on-chain dichotomy and why we think that it's good to push as many things off-chain as possible, but that does involve specific challenges that are unique to that. I'll talk about how I find intents as they are today rather disappointing. In a subsequent version, I did rename that from intents are meaningless to something a bit less extreme. And then I'll talk about money robots, which basically are solvers, keepers, haven't heard that term in a while, agents and such. And then I'll talk about the concept of automaton accounts. So first, Khalani, we operate in the solver space. We operate in the intent space. These we consider tools and components, but what Khalani really is a completely open network for arbitrary software systems to find each other, interoperate in an ad hoc fashion, and then to team up and accomplish a goal that none of those software systems could have done on their own. That's Khalani. In terms of off-chain versus on-chain, I think we all see that over time there's been a trend to move towards computing everything on-chain to computing off-chain and placing verification logic on-chain. Khalani, both Kevin and I come from UTXO background. In UTXO background, we see the extreme of this, in which the entire state transition is computed off-chain in a complete transaction, in a complete UTXO transaction that defines every single state transition that will occur. This is in contrast to, for example, Ethereum and related systems in which you send a message and the final computation is very ordering sensitive and is determined later, but the transaction originator does not know at transaction origination time what the final result will be in absolute granularity. So I would call that dichotomy basically verification-centric chains and architectures versus compute-centric. And intents actually do play a role in that they do delegate. They basically see them as a delegation primitive in which the outcome, the computation, is delegated to obviously other operators besides the transaction originator. And this usually involves, when you're working with an intent system, the intent system is only as expressive as the verification system, because you can only express in an intent what can be verified on-chain. So we have, and so when you need to use a proof system, there's a choice between what kind of proof system you're going to use. Cryptographic proof systems are very commonly used in the industry to outsource computation elsewhere. They're especially appropriate when you know what the computation is going to be, but you don't know, but you don't want to perform it yourself. Okay, and you don't necessarily know who's going to perform it, so you sort of outsource it. Intents, on the other hand, are a level of abstraction higher. They're actually an abstraction over computation. You do not need to know exactly what the computation is that is required to achieve the goal that you're trying to express, but you do need verification conditions to ensure that the goal is actually achieved. So intents are useful when you want to outsource the computation and you don't know what the computation actually is in granularity. So that's great. Intent systems, rollups, everything that moves computation off-chain is good because on-chain resources are expensive. The problem, and this is something we dealt with for years, is that when moving computation off-chain, you lose the inherent interoperability. When all programs are in the same space on-chain, all these contracts, you have that composability, the Legos, the programs can be combined in various ways, and they're all discoverable to more or less extent. When you move things off-chain and place the majority of the work off-chain to off-chain services, that composability is lost. So you get you utilize the on-chain resources better, but basically everybody has to rebuild the entire stack vertically for all of the off-chain systems, or you have to go meet with the team that's running some sort of off-chain system, do some BD, sign some agreement, or do some sort of integration like that. And so Khalani's philosophy on intents is not that they're meaningless, actually. It's just that they only get us part of the way there. They're not a value prop. I don't really think they're a value proposition on their own. We see them as downstream to a more fundamental problem, which is off-chain coordination more generally of all off-chain services, be it solvers, agents, keepers, various other kinds of services. And so we see intents as a tool for coordination, but you have to have a valuable thing that you're trying to coordinate for them to be, useful. Furthermore, like I said in the beginning, intents are only as expressive as their verification systems. So we see a lot of very application-specific intents today. And this is a common theme in the industry, is to basically remove silos by just actually moving them somewhere else. And we're seeing this again with intents. The proliferation of application-specific intent systems and the proliferation of standards associated with those also, they place silos on the intent systems and the operators. If you're a solver or off-chain infrastructure for one, it's not necessarily the case that you are a solver or off-chain infrastructure for another. And so we really want to actually see these silos go away. And that's why we're creating a 16th standard. I'm just kidding, we're not actually doing that, but somebody mentioned that XKCD comic earlier. So intents are the on-chain part, the expression, the coordination primitive. There's also all of the other stuff off-chain. Call them money robots. And money robots today are basically lonely and cynical. They're lonely because they are also siloed. Agent-to-agent coordination is in its infancy, and it's quite hard. Also, natural language is, I've seen some sort of demonstrations and such of having multiple agents talk to each other. This is novel and it's cute, but it doesn't actually work. I'm not going to give, and I think I speak for many people, I'm not going to give them a large sum of money to go spend on my behalf today. And so the silos abound, and there's a trust problem. I don't trust these agents to actually make me money and not lose it in some cases. Also, agents don't necessarily trust each other. If they are doing things that are important or critical, they need to be able to trust each other, and we need to be able to trust them. So there's a trust problem in two senses. And we need to solve both of these if we want agents to basically be able to actually collaborate, come up with plans and execute them, and ideally sort of fulfill the goals given to them by human beings or other agents operating on behalf of human beings. So we believe that automaton accounts are a solution to this. Automatons is a new account model that we think is very agent forward, and we've already implemented this on our testnet and mainnet, and so I'm going to talk about basically what automaton accounts are. Okay, so automatons are accounts because they have stewardship and spending capabilities over assets. These assets typically come from users, and they can operate though without the creator's intervention. They can operate on their own, spend on their own, hopefully do other things on their own. And the reason that they can do this is because instead of having code that directs their path of execution, they instead have a constraint system attached to them. This constraint system is basically, when I talk about intents, and intents are only as expressive as their verification system, one can think of the constraint system as the language through which you express what the automaton's capabilities and responsibilities are. So automatons have a constraint system, and they have assets at the very least. And we see the job of solvers then to basically race these automatons, make them take as many steps as possible, and make as many automatons take as many steps as possible. And the constraint system, very importantly, is machine readable and it's also human readable. So I like to say that it's semantically transparent, another term that Khalani uses regularly. And what this means is that signing for end users who are maybe constructing an automaton actually understand what the automaton's behavior will be. This is very important, actually. I think we actually saw that very recently with a fairly large loss of funds by an exchange. And but it's not just automaton, it's not just for humans that it's important. It's also important for all of the machines, the solvers. And we could see this problem maybe, the importance of semantic transparency by contrasting it with hooks that Uniswap v4 introduced, a very innovative design. But the hooks add this customized bespoke logic, right, to the pools and to trades. The problem is that the meaning of those hooks, the rules that they enforce, are not necessarily easy to extract from the on-chain program. Due to this, one might expect there to be sort of a convergence towards a few hooks that do a lot of things, but it creates a routing and discoverability problem for solvers in off-chain systems. So automatons do not have this issue because the meaning of the rules constraining an automaton to take a step are readable by the machine. So again, they are different from what we think of as a contract account in that they are not called by sending them a message or a function, which then performs some computation. The entire computation is the step of the automaton is computed off-chain. If it succeeds, that is exactly what happens. The step is predicated on the previous state of the automaton. So you're not going to have some sort of read then write conflict that's common in account models. Furthermore, all of the agents off-chain that are seeing your automaton, which is every agent and every solver and every solver network that's Khalani enabled, can understand every constraint. When a solver triggers the automaton to take a step, that step will be enforced. Basically, compliance, solver compliance is enforced, and so you can give the automaton your money instead of giving an agent your money. And it's basically the same thing, but when you give the automaton the money, you could trust that it won't spend it in some stupid way or like use Tornado Cash in an area where it's illegal or something like that. Furthermore, automatons have an important kind of composability, right, and interoperability. Just like if you have 10 different intent systems, even if each of them require bespoke and hard-coded integrations, it would be nice if, at the very least, one could express compositional intents over multiple intent protocols. One can do this with automatons because automatons can, their state transitions can be predicated on the state transitions of other automatons. And so this allows a natural form of composability, which again doesn't require a human in the loop because it's all based on an on-chain pub-sub model across all different chains to which Khalani is deployed. So if automaton is constrained by, if an automaton steps have these constraints that guard each state transition, one can think of each of those constraints as an intent. The automaton's constraints that are active depend on the state that it's in. So one can also think of automatons as intent generators. In the simplest case, though, an automaton that takes one step and then reaches its final state and dies, basically that's an intent, and those are what most intents are today. Again, automatons do have that pub-sub style composition. And in order to get, in order to future-proof the system, it's important that the underlying base language in which constraints are expressed can be extended in a way that's compatible with other extensions, such that you're not introducing silos where, again, it's very important that solver networks who are integrated with Khalani can automatically integrate without any effort new intent systems that we represent with our automaton system. And so Part of that is, of course, the trust model. Different applications and different developers and teams and such will have different degrees of security and verification, different verification systems that they may need, and so this needs to be modular in a way that's also composable. And that is what automatons enable, and that's some of their main differences from intents. And actually, that's supposed to say no questions, because I was informed that there's not time for questions actually. So, so that's it. Thank you.